Alrighty, kind of a loose ends cleanup now of a few more things we're supposed to know about parallel line transversals. So again, we're going to talk about parallel line transversals, but this time we're going to compare them to non-parallel transversals. And it's important because we're going to see how some of the properties we have can work backwards for us as well. Okay, so we're going to examine a non-parallel transversal. We're going to compare the two. We're going to talk about properties of parallel line transversals a little bit, and we're going to use them to solve a tricky problem. So we're going to see sort of two major things here. The first thing is kind of a working backwards bit, and the second thing we're going to deal with is another application or a tricky problem. So a bit of a loose ends video here. Okay, so examining a non-parallel transversal. Okay, so remember that we had all those rules for parallel transversals, that corresponding angles are equal and alternate exterior angles are equal and all those sorts of things. Well, if the lines are not parallel, and this is just another GeoGebra creation here, what you'll notice is that we've got these angles that are behaving correctly, you know, sort of vertically opposite or equal, etc. And we've got these angles that are behaving correctly as they correspond to each other, but there's absolutely no connection between those two things. So if I can't connect the two things that are going back and forth like that, well, that means that my lines are not parallel. So this works two ways. I know that if my lines are not parallel, the properties that relate one group to the other don't connect. And I can use it the other way as well. If my properties don't connect, I know the lines can't be parallel. Okay? So for corresponding angles, we're equal. Alternate interior angles are equal, alternate exterior angles are equal, same side interior angles are supplementary. All that is true if we're parallel. If we're non-parallel, none of those apply except for this one. This one is going to be okay because the vertically opposite angles don't really depend on the fact that I have two lines anyway, okay? So vertically opposite angles, those are still okay, but the rest of these, none of those actually work if we're talking about non-parallel lines. So what that does is it allows us to play a little trick. Instead of saying, well, okay, I've got parallel lines, now I can figure out some angles. If we know some angles, if the angle properties of a transversal are true, that means that the lines are parallel. So for instance, we have two examples here, and we have to determine whether the lines are parallel. And just on sight, they look pretty parallel for both of them because the angles are really close. But I can see that this angle is 54.88 and this angle is 54.88. Okay, so we're measuring these two angles and we can see that those are alternate exterior angles, and since they are equal, that means that my lines have to be parallel. That's the symbol for parallel. And over here, I can see that these two angles that I have, one of them is they're alternate and they're interior, and alternate interior angles are supposed to be equal if the lines are parallel. These are not equal, so since they're not equal, we are not parallel. Okay, so that's going to be a little bit of a trick that we can use, sort of using our theorem backwards. Instead of using the fact that we're parallel to find angles, we can use the angles to determine whether or not we're going to be parallel, and that'll help us in some other problem situations when we get to it. Okay, so the second thing I wanted to sort of throw at you was, let's say that we knew our lines were parallel. Okay, so let's say we're given that these two lines are parallel, and we want to find out not just what some angles are, but sometimes we'll get these algebra questions where we have to figure out what the value of x is. Okay, so it just becomes about writing an equation. So let's see what we can do. These are, I guess they're same side exterior, which we don't really have a mention for, but what we can do is we can say, well, look at this one up here. That's going to be corresponding to this angle down here, so I guess they have to be congruent. So this one would be 2x plus 10. And therefore, these two angles would have to, since it's along a straight line, add up to 180 degrees. Okay, so I can say that 2x plus 10 added to 3x plus 20 should give us 180 degrees. So we have to be able to work with this stuff algebraically to determine an unknown value, not just pick out what the angles are, but sort of solve some equations with it too. So if I add all this stuff together, collecting like terms, I'm going to have 5x plus 30 equals 180. So I'll subtract 30 from both sides here. and that'll give me 5x equals 150 degrees, and then dividing by 5, we have that x is going to be equal to 30 degrees. Okay, so that seems to work. So it's just about, sometimes we get these tricky questions, and when we get those tricky questions, we can just solve an equation. So figure out what equation you have to set up and then solve it. Okay, so some of the key ideas here for non-parallel transversals: none of the properties of angles in parallel transversals hold, except for vertically opposite. But vertically opposite is, of course, not really a transversal property. That's just any two lines that run together, okay? So conversely, if any one of the properties fails to be true, the lines are not parallel. So if any one of the other properties is not true, the lines are not parallel. And if any one of the properties is true, the lines are parallel. So what we can do is we can use the sort of same ideas backwards. If we know they're parallel, that helps us find the angles. But if we already know some of the angles that are supposed to be equal or supplementary, and they actually are equal or supplementary, that tells us we're parallel. If they're not, it tells us we're not. Okay? So this can be used as a test to determine if a pair of lines is parallel. I think are parallel. When solving a parallel transversal problem, use the properties to create an equation and solve for the given variable. Okay, so that's when we have to do those algebraic things. So sometimes it's just not a matter of finding angles, but it's a matter of setting up an equation with the sort of ways that we have to balance all that stuff out, and then we can solve for our variable. Okay, hope that's helpful. Practice questions next.